Hi everyone. I have a topic of the AI symbiote augmenting, not replacing the smart contract auditor. So we gonna focus on more how we can use AI for our benefits or build custom AI tools for our audit work, and more importantly, how to think on improving it so that you can customize it for your own workflow. So before I start, I want to tell you guys that AI isn't some alien overlord that is coming to steal your job, and
You
that's
sure?
one of misery. That's one
Please
of
promise
misery
it.
we are facing. Well, then we have to switch.
Awesome.
Yes. So you can think of it as more like Venom from the Spider-Man comics, that a symbiote that bonds with you gives you superpower to find some common bugs in our smart contract quicker than before. And we will also see how there are many areas and where AI won't be much efficient to use, and how we as an operator will survive and all those stuff. So yeah. So before I go into this research paper, so it's it's more important to understand that we are talking about tools that will make us smarter, not obsolete. And this paper on HG80 is a prime example. So I have been building my own tool based on this, which I might publish at the end of Q3 25. So let's break it down step by step and keep it technical but beginner friendly on the AI side. Because since I know you are all Solidity wizards, but may not deep into the neural networks yet. So we will aim for 10 minutes. So buckle up. Yeah. So here, the truth is current detection methods suck because they have high false positive, low accuracy, and what about the manual audits? They are very time consuming and expert dependent. So we also use some automated tools like Oyent or Mithril for the symbolic executions, simulating all the possible paths or the formal verification, math proofs of correctness, but they miss stuff or flag harmless code. So we have rule-based system as well, which are very rigid. So they rely on the prediction patterns. Like if you see message.sender.call, scream reentrancy. So yeah. So but real vulnerabilities are sneakier and hidden in complex logic. So let's start with the figure we have here for the overall design of this strategy that they are using. So to give you a high level view, it's a flowchart starting with smart contract source code acquisition and pre-processing. So moving to compile smart contract source code, then Solidity parser for syntax info and an abstract syntax tree. It branches to add semantics via SCG, which is semantic contract graph, and CFG control flow graph. Then feeding into the node grammar and semantics, then feature vector, HGAT, and output. This is overview, and we will go deep into this, how it is working. And it's a full pipeline from raw code to flagged vulnerabilities. So this shows how syntax and semantics layer for better analysis. So let's go technical in this. So everyone knows that smart contracts are written in Solidity, compiled to EVM bytecode, but this paper works at the source code level. They model the contract as a graph. Nodes are key elements like functions, primary nodes, example with withdraw, variables are the secondary nodes like balances. And then we have callbacks, example, external calls, edges shows the relationships like data flow or the control flow. So in this figure two, you guys can see that there's a code snippet on the left, a simple contract with mapping, total supply, deposit, adding to the balances message dot sender, and the withdraw checking for the balances being positive, sending via message dot sender dot call, and setting balance to zero. So on the right, we have graph where we can see red nodes F1, F2, F3 are the primary functions. Team S1 is to S3 are the secondary variables like balances, and the yellow C is a fallback. And the arrows have their own functionality here, and edges like E1 to E14 connect them from E1, like even from an F1 to S1. So this turns code into a visual network, spotting vulnerability paths like the unchecked call in withdraw. But graph can get huge, like thousands of nodes for a big contract, which makes training slow and prone to overfitting. So the model memorizes what is overfitting is the model memorizes junk instead of learning real patterns. So contribution here is that they use some graph contraction. They shrink the graph by merging secondary and the callback nodes into a primary ones if they're tightly connected. And mathematically, node features becomes this function xi is a f of f primary, the summation secondary, and summation of callback. So this speeds up processing and avoids bloat. And the fun fact is it reduces the nodes by up to 50% without losing any vulnerability information. And here, figure 3 shows the contract after shrinkage. And you can see the three red primary nodes F1, F2, F3. And edges are bundled like E1, E2, E4 from F1 to F2. It's simplified triangle graph and demonstrating how contraction collapses complexity while preserving the flows perfect for efficient AI processing. So,
One thing in there, one thing in there, Samit. So we're talking about reducing nodes and keeping information, keeping consistency, right? But how do we make sure that no vulnerabilities? Because if I'm reducing nodes, I'm also increasing complexity in a way, right? Because I'm trying to be more precise, which could open the door to subtle and very hidden vulnerabilities. How do we combat that?
yeah, that's an excellent point, actually. So, I have pondered this a lot, and especially in audits with inherited contracts where data flow can be indirect. A contraction is a rule based on tight connection, for example in degrees or the out degrees. So it preserves key path, but yeah, the edge cases could slip through if a vulnerability is in a loosely connected node. So critically, the paper tests on a real data set which show no significant info loss with accuracy holding steady. So to mitigate what you just said, we could modify it with the auditor overrides, as I mentioned earlier. Flag ambiguous mergers when in the step from figure 2 when we are shrinking the nodes for the contracts, we can we can modify it and flag some ambiguous mergers for the review. For example, if if I will tell more about this how we can implement, and it's more of a balance between speed versus precision, but the symbiote approach let us human catch what AI compresses too aggressively. So that is where humans gonna shine in customizing those AI for our how our analysis should be, and not let the AI think what it should be, because human thinks better for more scenarios what may get wrong. And as Shantanu talked about the biasing, that that you can be using some AI tools which have bias that it will say that the code is secure and all, but it won't be. So we will see about biasing as well. Yeah. So moving on here, we have figure 4. So here's where we can modify this design to keep us human, us auditors in the loop. Instead of fully automating the contraction, we could add a human review step. So you can picture an interactive tool where AI proposes the mergers, but you, the auditor, add to veto or tweak them based on your domain knowledge. Like if a variable looks suspicious in a DeFi context. So this is hybrid approach, which ensures that the graph stays accurate to the real world risk, turning the AI into your trusty sidekick rather than the black box. So now the star is that is hierarchical graph attention network. But graphs are perfect for the code because Solidity has structures. statements in functions, functions in contracts, just like documents which have sentences and paragraphs. So HGAT uses attention to focus on important parts, mimicking how you auditors scan code. Like you don't read every single line equally. You zoom in on external calls or the math ops or the function that looks very complex, right? So this figure 4 dives into the model structure. So at the bottom we have function box with a simple graph of blue nodes and the edges, arrows up to the feature representation with stack layers, grammatical grammatical features with the pinks, then the semantic features, node features for the multiple sentences. So these aggregate into the sentence vector 1 to n. Here you can see, and in the similar with the attention alphas, and similarly then up to the function vector 1 to n with more attention, and hierarchical graph attention network layer combines that into the UF. And at the end, we have softmax function, which will classify it into the class 1, class 2, uh, these kind of vulnerability patterns. So it's like a pyramid, which have raw features at the base, increasingly abstracted vectors with the attention weights, focusing on key parts, and ending in the vulnerability probabilities. So, uh, so as the Shantanu said that we have very less data set in our domain, like for the solidity. So if we can get more data set, we can create more classes and we can detect more type of vulnerabilities. But yeah, that's actually hard to get. So to break it down, the attention part, it's like a spotlight in AI. So in a graph, each node looks at its neighbor, and then attention weights, let's say, pay 80% attention to this risky call, only 20% to this harmless variable. So it's hierarchical. First, sentence level, inside functions, then aggregate statement features with the attention on all logic flow, then function level, weight function by importance. Example, a payout function matters more than a getter function, right? That's what we do when we audit. Like we don't focus more on the getter because those are just one line code and we are retrieving the value of a variable. But where the main or important functions are there, payout, which is handling ETH or any valuable assets. So finally, at the contract level, we fuse everything for a vulnerability prediction. So, and what tweak I'm using for my own tool based on this is that to keep auditors in the loop here, we could enhance this HGAT with explainable AI techniques like visualizing those attention weights in a dashboard. So when a model flags a vulnerability, it shows you a heat map. Hey, I focus 70% of this external call because it resembles to the DAO pattern or the other similar hack patterns. So you can then dive in, verify with your own expertise, and even fine tune the weights for your custom audits. Like you want to focus more on the Oracle side, you can increase the weight of Oracle pattern detection and all. So this modification turns pure automation into a collaborative tool where AI highlights and you decide. And what about the results, guys? Let's go to the results section. Here you can see as the epoch increases, we have less loss for each of the vulnerabilities because we penalizes if it finds something very false positive, then we penalizes it. And then the results we have here is this is for reentrancy and this is HGAD. So Mithril got 60% accuracy and HGAT got 85, highest of them. So yeah, so this strategy is really good.
What we are looking at, we're looking at how efficient is symbolic execution, symbolic testing. What is this graph about?
Uh, Yeah. So, as I said, this is the result part of HGAT model that this research paper has implemented. So we are comparing how our AI that like we can use AI to detect some of the vulnerability patterns, but not the business logic ideas. So if we have data set which we can train on our model on that, so this specific strategy got more result on the accuracy as compared to the other static analysis tool we have, for example, Mithril, Slither. So many people use those tools. So here we can see the average time took by this model is 1 second, whereas Slither is only 5 seconds. So it's just a reminder that we are using those tools, those static analysis tools for our work, but it's time to like upgrade ourselves and get some superpower for example, like this HJT tool. And this like this is you can think of this as upgraded version of those tools only, which uses AI. So yeah, that was the implementation. But like this is really tough to implement, and like there might be some template or the boilerplate on the GitHub that someone had tried using this, so we can definitely use it. But I have something to share with you guys, that this is a very simple web page that I have built using the AI, and it's using Gemini models. And for example, many people uses AI these days for the audit contest, and I've seen lots of judges saying that nowadays there are lots of false positive reports, and the audit reports are the quality is very low, because what people do is they just copy paste their code into the AI and ask if you can find any bug or all those things. But what uh, what we should do and how we can use AI for like really find some good stuff in code. So this is where I'm going to demonstrate this tool, and I'm also going to share this code with you guys on the Discord, so that you just need to set up the API key of Gemini or any other model and use it. Okay, cool. So theory later, let's go to the practical. This is very simple implementation for the first demonstration, which is AI code explainer. And I'm going to use some example, for example, this, uh, and ask it for the explanation. So this is a simple execute function, and it has some require and all those stuff. So this will just analyze the code. But what more important is, we need to see how this tool is explaining it. So basically, what it does, it has section like what it does, and then security concerns, which might be and which might be potential, and how it might be used in a smart contract ecosystem. So next time, if you guys have some function which is very new looking for you guys, you can just copy paste here, explain the code, and it will do the job, like explaining it to you. And similar bugs, like I'm not saying to rely on this. This is just for the demonstration purpose. But what important is this, how it might be used. So you will get more information how code base or the project is working. So similarly, many people use a Certura CVL specification tool. So I have one example for this as well. If you guys like using it, so this gonna help you. This is basic governor contract, and we have some variable and state. So we are generating specs for the CVL, and let's see how it does. It might take some time because to think and implement these kind of CVL or testing code, it takes a lot of time. So let's wait. Yeah. So here we have CVL file where we can easily say that we got some invariant, and here is another invariant, that proposal state validity. And then we have some properties, for example, this and this properties for the execute function and all those stuff. So basically, even if you don't use CVL, you can find some interesting invariant which you might want to see yourself for the function or the contract, and this can help you in that. So it also explains the key features like what invariants do and all, and the state, etc. So this is more like how this is more from the code side of the things. But here we have one example for the MEV scenario. Let's take this example, and we will find if there can be any MEV scenarios in this type of projects or not. So example is our cross-chain bridge connects Ethereum mainnet earlier to Roller, and users can bridge assets by locking token on the source chain and minting wrapped versions on the destination chains. So, and they have some specific conditions like the 7-day challenge or 0.1% fee. And we will just use this tool here, and we will see how and what scenario we can get. So comprehensive MEV analysis, cross-chain bridge protocols. So here we have opportunities like these and attack scenarios and all. So this can help you think more on how things can go. And these type of bugs are not very easy to find using our static analysis or just using the chat app of any AI tool like Gemini or Cloud8. So it's difficult to think in this way. So these kind of tools are gonna help you to explore more attack vectors. You know,
What is this website? I mean, what is the address? Is this a tool? Is this a website?
this is my tool actually. This I'm gonna share as well in the
This
Discord.
is your tool. You've built it yourself.
Yeah,
Wow,
this is custom tool.
that's cool, man.
Yeah, yeah. So that's what I was explaining, that you can also build your own tools and use it use it how you want to use it in your workflow rather than just copy pasting the code and asking AI to find bugs. So like that's not how it's work for the AI.
So you basically have different models. You have different AIs looking at the smart contracts and analyzing it from different perspectives, right? Like MEV, and you're also looking at a specification for formal verification. This is really interesting. Is the tool free?
Yeah, so it's actually created using Gemini API only. So you need to you need to have API key for that. But yeah, this will be free in our Discord server. So coming back to the topic, it was AI versus human. So after all this development, are we gonna see that AI can detect some of the major exploit that happened in past? So, like for example, DAO hack, yes, it was classic reentrancy. So many AI can detect it. But what about poly network hack? So this have very noble attack surface. So maybe it can and maybe not, because the data that our current AI is trained, they might not be having this kind of novel attack surface or attack vector data in their training phase. So that can be a maybe. And for example, the curve finance hack that was for the Viper compiler version this. So this is for me, it's no kind of, because this was very specific to the compiler version. But it might, so with in between, maybe and maybe not. And we have Ronin Bridge hack. So why this is not detectable by AI? Because this was social engineering, not a code issue. So more like we can uh, even if we uh, get a AI which can find 100% of the bugs in the smart contract, it won't stop hacks being like it won't stop hacks that are going on, because there are lots of areas where we need to see how things can go wrong and all those stuff. So so those are still open for us as a security researcher to do more work and come up with a better plan. So yeah, you can use these tools yourself. I'm just gonna skip to this one, and this is related to what biasing uh, Shantanu mentioned. So I have one example here. For example, you can paste here your own analysis, what you got from the AI chat or AI output. So you can paste it, and it will tell you that is this analysis true, or do you see anything suspicious here? So taking the same example from Shantanu, that the AI model can be trained on field like that, whatever it gives, it will say that the code is secure. But here you can see that the analysis we pasted, there can be a lots of biasing. For example, training data bias, and how it's like what things are not mentioned in the analysis or the final report that can trigger this bias, or the cultural, geographic, then the temporal confirmation. So these are the biases that we need to check after we get our output or the result from the AI. So for this here, let's take example of confirmation bias. So the AI appears to be primarily seeking confirmation of known security patterns rather than actively probing for the absence of flaws or exploring alternative hypotheses of vulnerability. So it presents a very positive, unchallenged conclusion. So lots of time you're gonna see that there is no bug or all those stuff, and even if AI tries to think that can there be any other attack vector, then there's this biasing that we have in our models that's gonna say that no, it's appears secure, or there's no immediate vulnerabilities detected and all those stuff. So we always need to check, and we always need to keep human in the loop for this AI workflow. So yeah, and if we have time, I can give one example for this one as well. So this is more for the protocol team who are building their project, so they can think how they can deploy or orchestrate their own specialized agent for the project. So we're gonna see it for this example, where we have some NFT minting game and asset trading. So let's see. It takes a bit more time when it's about the when it's for the more output tokens. So we might need to wait few more seconds. Yes, so here we go. We have this multi-agent smart contract security workflow for P2E and FT game. And here it says that we need one coordinator agent. These, these all are AI agent, and this is telling you how you can orchestrate or create your own custom agent for your project so that it's more secure. So we have one coordinator agent that that's like the central orchestrator which will manage overall workflow and all. Then we have static analysis, which will use the tools like Slither, Mithril, and all. Then we need dynamic analysis and the fuzzing. Then we need economic modeling agent. So these kind of agents are like not available as such, and like one should know that these are very important for our project. So we have formal, then the MEV, then knowledge base of the threat intelligence agent, then the reporting and all. So uh, it also explains each agent in detail, what you will need, like the data schema and how you're gonna distribute the task and all. So yeah, so
It's very
that's
cool to see that we are using AI to as you said, to actually become a better, not really using it to replace, because we saw that pretty much all software being vibe coded right now, they are getting exploited almost instantly. Of course, from us that are developers or security researchers, for us, it's very much easier to explain, take care of this part of security, maybe make these credentials have a specific access route for these credentials. But for people that are just building these things, it's completely different.
yeah, absolutely. That's very right actually. And we need to be more careful about these things.
So that's very cool. Thank you very much. Just one question. Are you using a local AI to do that? Are you running Oyama? What is your process in there?
Here,
Yeah.
I'm using Gemini.
Gemini, that's
Gemini.
that's very cool.
Yes. So you can also get 2.5 Pro and you will get enabled this grounding option. But it will take more time. So for the demonstration purpose, I had this off. But if you use this, you're gonna get more latest result and more better output.
That's very cool. Thank you so much. Thank you so much, Summit. I mean, it was an amazing presentation. And now we're heading. I don't know if there's any questions from the team. Let me check it. So VI is asking if HGET is open source.
I'm not sure if it's open source, but you can definitely read this paper, and this is like available on internet. And I will also share the link for this. But there might be some variation of HGAT or similar because this you definitely have CNN type of strategy for the AI models for a smart contract auditing. Like this is GNN. Sorry, we have one GNN model which was proposed, and then we have GCN. So you have similar code, but like I'm not sure about the HGAT. But you can definitely modify one and build it.
That's very cool. That's very cool. Okay. Thank you so much, Summit.